Okay, here we are with number 7 in your practice problems. And the first thing that I want to mention is that if you're just working through the problems in order, you're probably going to have the same numbers in your in your worksheet, in your Excel sheet, as you did from number 6. So all your assumptions about the returns and the probabilities of the state of nature are probably going to flow through your example of number 6. In my case, I'm chunking up these recordings that I'm making, so I had to kind of recreate the information from number 6 with a different set of numbers than I used when I was making the other recordings yesterday. So that's why these numbers in the upper part of my spreadsheet are different than the prior recording. Okay, so this is the calculation of the weighted average or expected returns on these different types of investments given the probabilities of the different states of nature. And so now we move to number 7, which is looking to determine the expected variance or standard deviation, right? Because remember, when we look in the past, we look at the prior, average returns and prior standard deviations. When we're looking into the future, we have to take uncertainty into account and generate expected returns and expected variances. But the process is pretty straightforward, right? So in order to calculate the variance, you have to look at the difference. The variance is basically an average difference, right? And you're looking at the difference between, in this case for a stock, the forecasted return in a boom economy versus the expected return, which is defined as this 5.3% over here. So, and then you square that difference. So let's just go ahead and do that. So that our calculation would be the forecasted return minus the expected return. Close the parenthesis, use a caret to square it. Caret to square it. So that'll give us the difference squared in the boom economy. And then if we want to be lazy, which I always do, let's figure out how we can make this an absolute cell value so that we can just copy that formula over. And so I want to be able to pull my formula down eventually, but also pull my formula across first. So the way that we're going to do that is by keeping the column absolute for the moment. Right, so let's see how that works. Right, so now I am referring to the stable growth economy, and my cell reference is remaining where it should be, so I can go ahead and pull these out across the rest of the way. So that gives us our differences all the way across in these different states of nature. I need to change my column headings here. Obviously, I just copied that across as well. And recession. Okay, so now, right, we have our different squareds. We can go ahead, I believe we can go ahead and copy these right down. Let's see how that works. Okay, let's just verify that this is working properly. So this is picking up the corporate bond forecasted returns versus the expected returns, so that's good. The other thing is, you'll notice that these numbers here, because there are so many zeros involved, it gives you the numbers in exponential notation or scientific notation, and that's fine. It's still the same number. Excel is storing the right information. It's just that there's a lot of zeros. All right, so we can pull this down, and again, it is picking up the right columns. Okay, so now we need to calculate the expected variance. So that's the 14% times this plus 20% times that plus 52% times that. And as we recall, that is our Excel function called sum product. And so we can pick up these, make them absolute in the row value. So we're going to take the sum product of the probabilities and the different squares that we have calculated. Okay, there's that. And I think we can copy that down. Again, whenever you're dragging and dropping, you want to verify that it's all picking up properly. Interestingly, it seems that these variances for the government bonds and the corporate bonds are comparable, which I find interesting, although not comparable, they seem to be identical, which I find interesting. Whenever I see numbers that are coming out to be the same, I'm always a little skeptical. But when you look at the patterns of the numbers and how tightly they are clustered, it seems like actually that might be right. So we're just going to have to go through this and make sure that it is right. Now, the standard deviation is simply the square root of the variance. And actually, there's a couple of ways you can calculate a square root. You can take your number to the 0.5 power, and that'll be a square root. Or Excel has a function. If you just write SQ, it'll calculate it for you as well. So either way, we need to have these in percentages with two decimal points. And so now let's just go ahead and fill these all in. So let's see, the variance is, actually these need to be, my goodness, 6 decimal places. All right, so these need to be percentages. 1, 2, 3, 4, 5, 6. If the estimates for both the probabilities of the economy and the returns in each state of the economy are correct, which investment would you choose considering both risk and return? Right, so we have a stock investment with a expected return of 5.3, but a standard deviation of 10.25, so it's very risky. And it doesn't give you all that great of a return, whereas these corporate bonds have a very low standard deviation or riskiness, and they have a higher return. So the answer is going to be the corporate bond because it has the highest expected return and the lowest risk. So there we have it. And that, my friends, is how you do number 7 in your practice problems. So practice away. Okay, so for this next one, I've got it set up kind of like when I do your explanatory videos, your lectures, because I want to make sure that to have this one just really clear. Okay, this is starting to get a little complicated. Okay, so what we want to do, remember in the lectures I said I'll take you through the math in the context of showing you how to do the homework, right? So this is the math that shows how diversification serves to reduce risk and increase expected return. Okay, so our investor is thinking about investing in 3 different assets, and we have some data about the state of the economy and the returns on these different assets, right? And so I've gone ahead and copied this over into Excel for you. You're going to want to do that, right? And so what we need to do is figure out what are the expected returns and the risk from her investment in the 3 assets and, in a portfolio, and how do they compare with investing in asset M alone. So what they're giving us a little hint, they're saying find the standard deviations of asset M and of the portfolio equally invested in assets M, N, and O, right? So the first thing we want to do, step 1, is we want to find the expected return from an equally weighted portfolio in each state of nature. That is, we want to find the average here. So we want to find the average return for an equally rated portfolio for each of these states of nature, right? So you can go ahead and use the Excel function average, and just take the average of these three returns, and that gets you to your expected return from an equally rated portfolio, assuming that it is, this state of nature, right? We have not done any weighting yet. Okay. So the second step is we want to find the expected return on each individual investment. That is the weighted average, right? So this is where we use that sum product function. Right, and so for asset M, the expected return is 30% times 10 plus 49% times 7 plus 21% times -2. Okay, and we do that for each of these assets. Okay, so that's your second step in doing this kind of an analysis. And then after we've calculated the expected return for each individual investment, we can find the expected return for the portfolio in the different states of nature in a couple of different ways. Okay, we can just simply take the average of this, so that's what this calculation is, it's just an average, or we could verify that this in fact is the same as using that sum product. So the sum product was the average return in each of the states of nature times the probability in each state of nature, right? So mathematically, you can get to these same numbers from two different pathways. However, this gives us our expected weighted return from this portfolio. So we expect that we should be able to get 7.78% from this portfolio, equally weighted between these three assets in this sort of assumed state of nature, which is a weighted average of these three different situations. Okay. Now, the next thing we need to do is we need to calculate the variance. So right now, right, we've got the first expected return of investing equally in all three assets at 7.73%, 7.78%. And we also have calculated the expected return from investing in asset M alone. So let's go ahead and just make sure that we're on the right track here, 6.01%. Yep, okay. Now, the next thing we need to do is calculate the variance and the standard deviation of the portfolio that invests in all three assets. So for the equally weighted portfolio, we want to calculate the squared difference between the expected return in the boom state minus the average, and then the expected return in the normal state, right, minus the weighted average, and again the expected return in the recession minus the weighted average. So those are our squared differences. So we've got the squared differences in all of these numbers. If we take and do our weighted variance, just as we did in the last problem, where we take the probabilities of each state, multiply it by the squared difference, that'll give us our variance. And if we take the square root of the variance by raising it to a half power, that'll give us our standard deviation of 2.5, which we like, right? Great, that one's right too. Now, the next thing then, we need to calculate the, go through that whole rigmarole for asset M alone, right? So again, this time you look at the difference in the expected return of asset M in a boom state minus the weighted expected return squared, and you go through that whole thing. You get a variance of 0.00187, take the square root of that, and that gives you 4.33%. standard deviation for asset M. And so, right there was the mathematical explanation of how diversification works. Okay, I know it's a lot, right? Just practice this over and over again with the practice problems, and then you'll be able to do them in your real homework. And so that's how diversification works, by reducing the standard deviation of your portfolio. You can gain a better return for a lower risk. So a well-diversified portfolio is the key to a happy life. So we can increase our return by the difference between 4.3 and 2.5. So that's going to be (1.83%) better return, and decrease our risk. No, I'm sorry, got that wrong. Decreased our risk by 1.83 and increased our return by the difference between 6.01 and 7.78. So it's going to be 1.77%, I think. Yeah. All right, so that's how you do problems. What was this? 7 and 8, right? We will continue